First, listen a scenario we have from we get an idea where it is applied, for which problem we can use it. So, suppose we have scenario like we have five friends. From these five friends, four are boys and one is girl. And now girl decided to date someone. So she tell everyone to for the date which is best, which is best for the date. Okay. So these four friends are good friends. So they are discussing which one is among best for the girl. So they all are discussing that which one is best. So okay, so they are good friends, so they cannot uh, say that I am the best. Okay, so its self-selection probability is zero. So they are giving priority to the others, that which one is best for our friend. So this is how they are giving the priority. David Carlos thinks that Bob is best. Okay, and Bob thinks that the two links are going. Okay, Carlos Bob for David and Carlos. Okay, two links are going. Okay, these the links are going. They are called as outbound, ingoing links. Okay, ingoing links for the David and for Carlos it is ingoing links, and for Bob it is outgoing links. Okay, okay, we see get an idea about outbound or ingoing links later. Just see a view or get a idea about what is the situation. David Carlos thinks that Bob is the best one. Bob thinks that either Carlos Bob, oh sorry, either David or either Carlos. From these two, maybe someone is best. Similarly, Carlos thinks that David and Alex. From both these, any one of them can be best. Okay, so this type of situation is creating. So such type of situation we cannot get a perfect idea that which one is best, which is the right person for the lady. So that we cannot get a clear idea which one is best. So how we can select from these four for the lady? So such type of problem is solved by this algorithm, PageRank algorithm. Okay. So this is how they are giving priority. That Alex thinks for Bachelet, Bob can be selected. Bob thinks either Carlos or David. Carlos for David and Alex. David thinks Alex. So from this method, we cannot get any clear idea about the person which is select for the lady. That which one is best for our lady. So here we get an problem. We occur a problem that which one should be the Bachelorette pick. So, and we are not giving an, we are not correct, we are not getting the right answer that which one is best. So, so this is a problem solved by the ranking algorithm. Okay. So such type of problem is solved by ranking algorithm. From here we can learn, or the problem which is occur here for selecting such type of situations, the ranking algorithm is applied. If we go to the real world, we can see that from the website we have many websites. So which one website is best for the some particular topic which is searched in the Google search? Let's suppose a user is searching in the Google bar that for some topic that like group theory and application, which one uh, site is best for him. So how we can select it? So there are many websites for that topic. So that many from that website, which one is best is selected by PageRank algorithm, or maybe means PageRank algorithm is helps to provide the best page for that topic. Okay, so let's learn it. Okay, uh, this is an idea about we are how relating that graph and that page rank and algorithm. Okay, so nodes here we can say that nodes represent the document and edges are representing the hyperlink. Okay, the link B to A. B to A means from website B we are going coming to website A. From website A we are going to website D. Okay, from website D we are going to website E. These links are representing like this, or we can maybe use this as website, or maybe you can take it as pages. Okay, fine. So link analysis. Here we are using or finding a method using the link. So these are the link analysis algorithm. The three type of algorithm we have: page rank algorithm, weighted page rank algorithm, hits hyperlink, induced topic search algorithm. So here we totally focused on the page rank algorithm. So what is this page rank algorithm? Page rank algorithm. Okay, you just see a video where you will get a basic idea about the page rank algorithm. Just see it.
PageRank algorithm. When you perform a Google search, how does Google determine what order to show your result? One of the most important algorithm is Google used to do this called is Google PageRank, and its algorithm that attempt to estimate the importance of a website. What does it mean for the website to be important? Well, the web consists of pages. Actually, we have a lot of pages, and how to be important, which page is important, and what is the rank of the pages. That page can be connected. For example, the web the content for example, the website contains a lot of pages, and these pages are connected to each other via links. PageRank algorithm is generally determined a particular page is linked to have the many pages. It's like a important page. It's behave like it's important page. For example, is a page 4. The page 4 has a lot of incoming page links. So page 4 is a important page, and page 1 is no incoming is it. So page 1 is a list. But there is a problem with this approach. The problem is this: in this slide, as you see, we want to make our page as a important, so we make our lot of pages, and the lot of pages linking to, we want to that particular page the important, so lot of incoming page is coming. So as you want, we want to make this page, my page is important, so it will be important according to PageRank algorithm. So it's time to be modified for this PageRank algorithm. How to modify and how to solve this problem? The solution is one is called as random surfer model. Random surfer model is work is random surfer model is calculate a score of the party every node, and a idea is that begin on some page chosen at random, and they random pick a link from that page to another page that they visit. The random surfer keep repeating this process. In this process, we will keep score, will maintain a count of how many times our random so prefer visit each page. Each time will update page score. Which page have a highest score, like it page 4 is 36%, that give a highest priority, and it will give a higher rank in this page rank algorithm. But again, there is a one more problem in this page rank algorithm. They maybe disconnected each other pages to. There is a still one more problem with this approach. If link is disconnected, uh, and our algorithm is always moving in one component, never coming to the another component. So for solve this problem, we use as a dumping factor. Dumping factor is like a, if dumping factor is a constant, in dumping factor value is of 80% or 20%. For 80%, it is moving 80% of times in this component, and another 20% in another component, and find same the calculate the score of the each node and find the priority of this. This is a source code of the page ranking algorithm. And page ranking algorithm page surfer model is using Markov chain to moving to each other component and calculating. As you can see, one more thing, please don't do this to improve your page, because nowadays Google is being smart and using lot of algorithm as a background. For example, if you're using link harming, black hat optimization, yeah, some kind of spamming, yeah, some kind of this algorithm is called as Google Panda. Google Panda is look as a poor user experience, duplicate content, plagiarism, thin content, keyword stuffing, user generated scam. It's checking inside using these content. It analyzes your algorithm ranking, page ranking, and upgrade down and up your rank, page rank inside. Thanks.
Calculation of PageRank. This formula is give the PageRank to the node. Here the D, PR, T1, CT1 have the meanings. Okay, just see it. What D? D define the damping factor. Okay, the damping factor value is occur between 0 and 1. But during many experiment and analysis, the default value we are taking as 0.85. And PRT1 is the page rank of pages TI, which link to page A. It is the page rank of the node which are linking to the web. If we are calculating page rank for A, then many nodes are linking to the node A, and if from these links only we are calculating the page rank of A. So all that links or all that nodes uh, for that nodes, what is the value of page rank of that node A? It also have meaning for that node we are calculating. Whatever I am saying, maybe you don't get a clear idea, but when I give you an example where you will learn all the meanings and all the meanings of this formula, or you will get a clear idea. Okay, so just now listen it what I am saying. CTI is the number of outbound links on page TI. CTI means what? It is the number of outbound links on page TI means outbound means for that particular node how outbound links, number of outbound links, how much outgoing links is going. This also depend on the calculating page rank of A. And N is the number of in link of page A. How much linking link is coming. Okay, so this is also example. I will give another example, or I will. We have a simulator, PageRank simulator. There we can learn uh, learn about the PageRank algorithm very clearly. This example also you can learn from it here. Or I'm giving in a basic idea or representing how we are using the terms and how what is the meaning on whatever. Just learn from it. P being referenced by pages Q and R. So P is what is the meaning? Pages Q. Q is referencing to P and R is also referencing to P. Okay. Okay. The second line is Q and R has two three outlinks. Q has two outlinks. Q has two outlinks means from Q one link is going to P and one link is going to S. So these two links are called outlinks. Okay. Or what is the meaning of inlinks? Inlinks means for Q inlinks is P to Q and R to Q. Uh, uh, these links are P to Q and R to Q. These links are called inlinks. And here we see there is no dangling links. Means there is no node present from here where the outlink no no where there is no outlinks present. Everyone have outlinks, so there we don't have a dangling links. Okay, the formula is defining the page rank, calculating for page uh, node P. Okay, the one minus need. Okay, for if we are calculating the page rank for P, then it is depend on the out links which are coming to the P. Incoming link for P is by node Q and by R. So Q and R both are dependent for calculating the page rank of P. So it depend on the node Q and R also. So okay. So 1 minus d is a damping factor plus d PRQ. If we go to PRQ, define the page rank of Q divided by 2. What they do, T is the outgoing link for Q. How much outgoing link is going for Q? For outgoing link in Q is Q to P and Q to S. So there are two outgoing links. So then value we will return as 2. And similarly for R, okay. So this is the formula where we can get an page rank for the particular node. The page rank algorithm does not rank the whole website, cannot rank the whole website. It is only used for particular page. For only particular page, we can calculate the page rank. It is determined for each page individually. For each page, we can calculate it individually. For P, it is calculated individually. For R, it is individually. Q, it is individually, and for S also individually. PageRank of page A is recursively defined by PageRank of those pages which link to page A. The PageRank page is recursively defined means what the it for no particular node recursively it is calculated for particular times after some time it will again calculated and it will apply to give a priority. Okay. Iterative method means what? First of all, we will give the all nodes a page rank one, and according to the outgoing links and incoming, we calculated the value of page rank, and iteratively again we can calculate it again. The things is present here. Okay. So now go to the page rank simulator. You can understand a good idea about this thing. Okay. This is the page rank simulator. It is already present. Okay. So here, this is the formula we are using for calculating page rank. Here we have scenario like three nodes is present A, B, and C. Okay, this is the page rank calculated by using this simulator and this graph defined. We will see all this. First of all, just see the working. What is the simulator is working. First of all, the page rank of all pages is giving that 111 default. Okay. Now we are using the formula. Damping factor is 0.85, so 1 minus the value is 0.15, 0.85. PRB divided by CB. PRB and C are the nodes from where the incoming links for A is going. From C, we can see that this one is incoming link. From B also, the incoming link is so B and C depend will be going to be dependent for calculating the page rank of A. So for B, the page rank is 1 and CB what the outgoing link for B. Outgoing link for B means from where what, how much link is going from B going to link A is also from B C also link is going. For two links for C also the link is going. Okay. Similarly for B we can see that 0.85 and 2. Similarly for C also. So here we get an idea. So this the value now the page rank of A is 1.425. Now the page rank for B is 0.756. Page rank for C is 1.077. Okay. So now these values are calculated for iteration 2. Okay. Now if we see PRB for B the page rank is now 0.756. So we are using 0.756 and those and again and remain our same values. For CB and CC are remain fixed. Okay. So for iteration 2 these are the values of page rank. For iteration 3 these are the values of page rank. For iteration 4 these are the values of page rank. So this is how the ranking is calculated. Okay. So if we see here the graph is representing page rank or iteration. For iteration 0 the page rank is 0. Page rank is 1. If after page rank 1 the values of page rank is going for page rank is calculating different. The values of page rank is distinguished for before. Okay, so page rank A is in the iteration 1, page rank of A is 1.425, 1.85, 2, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113 0.7564b, 1.0774c. Okay, in iteration the ranking, the in the topmost A is come. Okay, and always the A will giving as a priority according to this algorithm. Okay, or in this example. Okay, so this is the PageRank algorithm. Okay, so what we get an advantage about this algorithm? It pre-compute the rank score. It takes less time and hence it is fast. Means the rank score is calculating in very less time, or it is also fast. So it is the advantage. It is more feasible as it compute rank score at indexing time, not at query time. At indexing time, we are calculating the rank score, not at query time. So it is good for that we are calculating at the indexing time only. It returns important pages as rank. It return important pages rank is calculated on the basis of popularity of page. Okay. As more it is popular, the more links is going. So the more popular, the more rank is coming. Okay. So this is a disadvantage. Here we see or get more focus on the disadvantage. What is the disadvantage? So we can go for the other algorithm, or we can from here we can develop another algorithm. Which one? Okay. So we can see the disadvantage. From there we can develop a new algorithm. So just listen carefully. Disadvantage. The main disadvantage is that it favors older pages. Means what I want to say that if some new pages is coming and it if it is best, then how that the in links for that page is very less. So what according to this algorithm the page is if the page is older and the incoming links is we can say that incoming link for that page older page is much more large than the newer page. Maybe the new page is best, but we are giving priority to the older page, so this is the disadvantage. Relevancy of the resultant pages to the user query is very less. Relevancy means related text we cannot find. We are finding that which one is using more, that will occur first. This scenario is using in this algorithm. We are not going for the relevant area or relevant text. Okay, so this is the disadvantage. It leads to rank sinks problem occur. The dangling factor, which I am, which I say to you in the previous. Okay, so if dangling means it. Okay, let's read it again. It leads to rank sinks problem occur when it a network pages get in infinite link cycles. Okay, if the cycles link is going to this and this link, the dangling factor, and if go occur when a network pages get in infinite link cycles. Okay, if sync problem means the link is going to again and again that they are not going to the some node or pages where it is important, and we are just calculating that all the pages, and we are not get in. So we have a disadvantage if some node is present and where we are not capable of going to the links we are using, then we have the disadvantage. Dead ends are possible. Pages with no outgoing links. The damping factor itself. The meaning of deadline. Okay. So thanks.